Now, senior, let's continue from electron configuration. Now, electron configuration simply means the arrangement of electrons in atoms of elements. As you can see here, I've written here. Configuration simply means arrangement. Don't let the grammar scare you. There are two types of electron arrangement or electron configuration we use in chemistry. First one is the shell electron configuration, this, and second one is the quantum electron configuration, this. First, we will do shell electron configuration. Now, shell electron configuration is the configuration which shows the arrangement of electrons in the shells of an atom. You understand? Shell electron configuration only shows how many electrons are arranged in each shell in an atom. Electron shells are usually labeled 1, 2, 3, 4, 5, 6, and so on using numbers, or labeled KLMN and so on using letters. The shell number is referred to as small letter n. Now, the number of a shell tells you how many electrons the shell can hold maximum. You understand? The number of a shell tells you the maximum number of electrons that the shell can hold. For example, shell 1, and the formula we use for calculating the maximum number of electrons in a shell is 2n raised to power 2, where n is the shell number. For example, shell 1, which is the first shell close to the nucleus of an atom, can hold 2n squared electrons, where n is 1. You just put the shell number here in this formula, and you get what? 2 times 1 times 1. 1 squared is 1 times 1. So your answer will be 2 times 1 times 1, and that's what? 2. So the first shell in an atom can only hold 2 electrons maximum. Now let's go to shell 2. For shell 2, which is the second shell, the shell number is what? 2. The maximum number of electrons it can hold is given by 2n raised to power 2, where n is the shell number 2. So if you substitute 2 for n, you get 2 into bracket 2 raised to power 2. That gives you 2 times 2 times the 2 outside, and that gives you what? 8. So that means the second shell of an atom can hold 8 electrons maximum. Let's do it for the third shell, where n is equal to 3. When n is 3, we are in the third shell. Now, in the third shell, the maximum number of electrons that the shell can hold is 2n raised to power 2, where n is 3. That gives us what? 2 times what? 3 times 3. And that's what? 18. So the third shell can hold a maximum of 18 electrons, and so on. So when you get to the fourth shell, to calculate the maximum number of electrons the fourth shell can hold, just do 2 times 4 squared, and that will give you 36, and so on. Let's go to shell electron configuration proper. We are doing it for the first 20 elements in chemistry. Element number 1 has atomic number 1, and its atom has what? 1 electron. 1 electron means that you have to put that electron in the first shell, and the first shell can take a maximum of 2 electrons. But hydrogen has only 1 electron, so its configuration will be 1, meaning 1 shell containing 1 electron. This one means hydrogen atom has just 1 shell, and that 1 shell contains 1 electron. So the shell will be, represented with this diagram. Now, helium is the next element. Second element in chemistry is helium. Its atomic number is 2. So an atom of helium has 2 electrons. The 2 electrons can occupy the first shell. So that means we are going to just have 1 shell holding what? 2 electrons. So its shell configuration is what? 2. The shell will look like this. You understand? A single shell with 2 electrons in it, like this. So Let's go to the next element, lithium. The atomic number of lithium is 3, meaning an atom of lithium has 3 electrons. An atom of lithium has 3 electrons. So, how do we do that? The first shell will take 2 electrons, and that's the maximum it can take from what we did earlier. So the second shell will take the remaining one. So we write the configuration as what? 2, 1, meaning that there are 2 shells, in an atom of lithium, the first one containing 2 electrons, and that the second one contains 1 electron. So that's that. Beryllium is the next element. Beryllium, an atom of beryllium has 4 protons in it, and 4 electrons in it. So 4 electrons, the first shell will take 2, the second shell will also take 2. So that's 2, 2. Let's go to 2, 2 means first shell will take 2, second shell will also take 2. These shells, other than using numbers, you can also represent the shells with letters. You can call this one shell K, shell L, and so on. So sometimes we use letters, but in this case we use numbers because we needed to calculate the maximum number of electrons each shell can take. Let's go to boron. An atom of boron has 5 electrons. 5 electrons, the first shell will take 2, the second shell will take the remaining 3. That's 2, 3. Let's go to carbon. An atom of carbon, the atomic number of carbon is 6, so an atom of carbon contains 6 electrons. How do we fill 6 electrons into the shells of carbon, or into the shells of a carbon atom? The first shell will take 2, the second shell will take the remaining 4. So its electron configuration, shell configuration will be 2, 4. Nitrogen 2, 5. Oxygen 2, 6. You can see the diagrams here. Nitrogen 2, 5. Oxygen 2, 6. Fluorine 2, 7. Neon 2, 8. Can you see that? But on getting to neon, neon has 2 shells too, and the second shell is completely filled up. So we say neon attains a stable octet configuration. We call this a stable octet configuration. So we will be using that later. Just take note. All of these ones did not attain stable octet configuration, but helium 2 attained stable duplet. We call this configuration stable because all the shells present in the atom are fully filled. When the shells in an atom of an element are completely filled up with electrons and cannot take more, we say that the configuration is stable. So let's go to sodium. Now, sodium, the atomic number of sodium is 11. So an atom of sodium has 11 electrons in it. The first one will take 2. The first shell will take 2. The second shell will take 8. But we still have 1 more electron to go. So that 1 electron will occupy the third shell. Let me draw how that looks here. This is how that looks. So first shell will take 2. Second shell will take 8. First shell will take 2. Second shell will take 8. And when the second shell is fully filled with 8, it can't take more than 8. We discussed that earlier. We, create another shell to put this last electron. So this configuration shows that there are 3 shells, and each one, the first has 2 electrons, second has 8, and the third contains 1 electron. Let's go on. We are still going to 20. So let's go to 12. Magnesium. An atom of magnesium has 12 electrons in its shells. There will be 2, 8, 2. First shell will take 2. Second shell will take 8. And the third shell will take 2. So the configuration looks like this: 2, 8, what? 2. So that's how the configuration, that's the configuration of magnesium. Now, number 13, aluminium. Aluminium should have 283. Shell electron configuration of aluminium should be 283. You must be getting the hang of it now. So 283, the first shell can take a maximum of 2 electrons. First shell can take a maximum of 2 electrons. It will take 2. Second shell can take 8. It will take 8. There's enough to fill into it. Then third shell will take the remaining 3. So after aluminium comes what? After aluminium comes silicon. Silicon is an atom of silicon has 14 protons, and it will also have 14 electrons. So first shell will take 2, second will take 8, the third one will take 4. 2, 8, 4. I don't want to write everything again because of my time. I'll just put it here for you. 2, 8, 4. I hope you understand that. Just to manage our time. It's time for prayers. I have to quickly join that. But we can finish it before I join them. So let me do this. 15. 15 is what? Silicon phosphorus. Phosphorus, an atom of phosphorus has 15 electrons in its shells. So same way, there'll be 3 shells. The first one, let's fill it, can take 2. Second one can take 8. Second one can take 8. And the last one, we take the remaining 5. The last one, we take the remaining 5. I hope we are accurate here. Okay. So the configuration of the shell electron configuration, I'm on my way. The shell electron configuration of phosphorus will be 285. 285. Let's do sulfur, 16. Sulfur, I need to be fast. Sulfur must be 286. Sulfur must be 286. So first shell 2, second shell 8, third shell 6. I'm not going to write the electrons properly. Let me just put the numbers there for you. I'm sure you understand it, what it means. So next, excuse me, light green. Next is what? Sulfur, chlorine. Next is what? Chlorine. Now, chlorine 2. An atom of chlorine has 17 electrons in it because the atomic number of chlorine is 17. So its atom has 17 protons and it will have 17 electrons, 1 neutron. So 17 electrons, that will be 287. You understand? There will be 3 shells. First one containing 2 electrons, second one 8, third one 7. So if I'm to draw a diagram for the shells, it will look something like this. Let's just make it sizable. 2 electrons. I have to draw once in a while so that it will not look like we start doing another topic within this. So 287 like that. So let's go to argon, chlorine. After chlorine is argon, 18. Argon, 18. Argon is 18. That's 288. That's what? 288. So first shell, 2 electrons. Second shell, third shell, 8 electrons. Now, almost all laws in chemistry have exceptions. And you will see an exception to this law here now. 288. 288. Meaning first shell 2, second shell contains 8, and the third shell 2 contains 8. Now, 19. Potassium. Potassium. Oh, sorry, I've not been writing symbols. Potassium is K. Argon is AR. I'm sure you know all that. Now there's an exception here. Normally potassium, I'm supposed to fill it 2, 8, 9. Because this third shell can take 18 electrons. But we don't fill all the 9 electrons into the third shell. We fill it 2, 8, 8, 1. After filling the first 2 shells, it is only 8 out of the remaining 9 electrons that go into the third shell. The last one goes into the fourth shell. That's an exception. And there's a reason for it that we treat when we do quantum electron configuration. When we do quantum electron configuration, you see a reason. You see the reason for that exception. So that's what going to be 2 electrons, 8 electrons, 8 electrons, 1 electron. So that's an exception to our rule that we get to fill one to the maximum before going to the other. There are rules in chemistry. There are general rules and there are exceptional rules. There are not too many rules in chemistry that don't have exception. Almost all of them do, except for a few. For example, there's a rule that says all nitrate salts are soluble. I think that one has no exception. All nitrate salts are soluble. But other than that, and maybe one or two others, almost all other laws in chemistry have exceptions. So this is one we are looking at here. The normal thing would have been to fill the 10 electrons into the third shell. You understand? Calcium is Ca. The normal thing, the usual thing would have been to fill 2, 8, and 10. But we don't do that because of the exception. It is only 8 that go into the third shell. The last 2 go into the fourth shell. So you will understand why this happens. You understand why this happens when we get to quantum electron configuration and we do subshells of main shells. All these main shells have subshells, and the subshells also have orbitals. So when we learn that, you understand this exception. All right, this is everything for now on the shell electron configuration of the atoms of the first 20 elements. So this is how electrons are arranged into the shells of the atoms of the first 20 elements. We will treat quantum electron configuration by God's grace in the next video. Thank you.